So this follows on from the SABR link video that I did, and we will now look to see how we can potentially improve this gear design using the parametric sweep function within SABR. So if we switch back to SABR, just to notice a few things here, we've got all of this information here because we've got the SABR link running. All of this information here, such as the tip diameter, I cannot modify within SABR because it's automatically done within SABR. So the tip diameter here, 54.091, is actually set within SABR. So for that, SABR is the master. However, you will also notice that within SABR, the center distance I cannot change. That is because that is set by the position of the shafts. So that information I cannot change within SABR. But the outside diameter information, if I change it here, will automatically, or face width, or pressure angle, or helix angle, will automatically change within the SABR model. So what I'm going to do is look at improving this gear design using the parametric sweep function. So we have a helical overlap ratio of 1.82, which is also shown in the SABR model, and I would like to improve that to get that above 2 if I possibly can. So what I'm going to do is use the parametric sweep function, so I have a bunch of inputs that I would like to modify to see if I can get the helical overlap ratio above 2. So the helix angle is one thing that I will probably have to change to get that above 2. The normal module, currently it's 2.4, and I'm going to have to reduce that, so I'm going to check between 2.3 and 2.4. The pressure angle, I'm going to run through a small range just to see if I can improve contact ratio and contact life. And then the profile shift, I'm just going to step through a series of values of profile shift for the pinion. And I need to lock the profile shift in the optimizer so that it will step through each of those values individually. When I come to looking at the outputs, I've already removed a series of outputs that I'm not particularly interested in, and so only these outputs I'm going to filter after I've run the parametric sweep. So the overlap ratio I would like to be between 2.03 and 2.1. The relative slide velocity ratio I would like to be between 0.95 and 1.05. That means that I will minimize the amount of sliding that I have and therefore improve the efficiency of the gear pair. And then also I have asked to keep the SAP specific slide ratio down below 2. This is a fairly crude tool, but it allows me to potentially keep the risk of scuffing low, so I will filter on those values. I've filtered on a 1.3 bending safety factor and then a surface safety factor of 1.05 for the flanks in both directions. I can run that study. In this case I have about 8,000 design variations. I haven't decided to look at face width. I'm going to leave the face widths as they are. But if I wanted to, I could increase the number of design variations. We've improved the memory handling now, so you can run as many as you want. The only disadvantage is that you end up with a large file size of output results because it will store all of the output results. But in this case, I'm happy with running 8,000 designs. It will not cause a problem in terms of the amount of RAM I have. The default number of threads is the number of threads you have on your machine -2. So if you have many more than 8 CPUs, which is all I have, then you can increase this number. It will increase it automatically, and the runs will be a lot faster. So I will run that, and then we will have a look at results in the next video.